Hi guys, so this is a problem involving kind of a riddle. We have two numbers and we're saying they add to 10 and when you multiply them together you get 10. And the problem is to find what the numbers are. Well, we can try, certainly we can try a 5 and 5 adds to 10, but 5 times 5 is 25. That's too high. We could try 1 times 9, that's close to 10. 9 plus 1 is 10, but that's closer to the answer, but it's not quite the answer. So here's one way to do it by algebra. So there's a couple different ways to do it. But in order to do that, there's just a couple of just some background information that you may or may not have. And I thought just to make this video somewhat self-contained, do a quick little review of some of these algebra terminologies and some of the facts. So first of all, terminology, monomial. When you're adding two things, the terms are the things that you're adding. Like when you're adding 5 and 7, the terms would be 5 and 7, 5 plus 7. The terms would be 5 and 7. So if you just have one term, that's a monomial, like 5x squared or 2. But if you're adding two terms, kind of like a bicycle has two wheels, that's a binomial. And if you're adding three terms, I should have had another term there, like x squared plus 5x plus 6, that's a trinomial. And then there's some facts about algebra that really it's a symbolic encoding of the laws of arithmetic. So one is the distributive law. If you have a monomial times a binomial, like 4 times 3x plus 5, the 4 can distribute, and that's how you can get rid of the parentheses. So 4 times 3x is 12x, and 4 times 5, that should be 20. And 4 times 5 there is 20. So that's one way to distribute, to apply the distributive law. And so that's a monomial times a binomial. You can also multiply two binomials. And in fact, you can multiply two trinomials and so on and so forth. But if you're going to multiply two binomials, there's a law that, and it really is, you're really using the distributive law a couple times. But it's an acronym you may have seen before called FOIL. First, outside, inside, and last. So you take the first of the two binomials, the first term, and you multiply them. 3x times 4x, you get 12x squared. And then the outside, meaning these two terms, the very outside of the trinomial, you multiply 3x times minus 3, you get minus 9x. Then the inside, you multiply 5 times 4x, you get 20x. And then finally L, the last, 5 times 3, 5 times minus 3, the signs are different. The answer is negative, negative 15. So what you end up with is this, and these two are what are known as like terms because it's kind of like comparing apples to apples versus apples to oranges. So they're both apples, so you can add them. So whenever you have the variable, a number in front of a variable, and the variables are the same, or they're the same variables to the same powers, you can add them. So minus 9 plus 20 is a plus 11. It's the same as 20 minus 9. And you end up with that. And usually end up with three terms. So you multiply two binomials and you end up with a trinomial. And then finally, going the other way, kind of reverse foiling. It's harder because it's not deterministic. You kind of have to guess and check. It's known as factoring. So in that case, that's when you're given a trinomial and you have to go back, try to find two binomials that you would multiply together to get the trinomial. And so you just usually what you would do is look at that first term and say, well, what would I multiply by itself to get x squared? And well, x times x. And then I just kind of guess and I say, well, 6. It's got something times something has to be 6. because that would be the L in the FOIL. So I'll try 3 and 2. If that doesn't work, I'll try 6 and 1. And when I cross multiply, I'll see if I get the 5x. And if you were to FOIL this, you'd see that you really do get that trinomial back again. You get x squared plus 2x plus 3x plus 6. So that's part of what we need. And actually, more than half of this rendition is probably going to be taken up in just the preliminaries, because it's really not that hard once you state the problem correctly. A little bit about square roots. So, for instance, 10 times 10 is 100. That's known as 10 squared. So the shorthand for that is putting this little superscript above it. 10 squared is 100. That's the same as saying the positive or the principal square root of 100 is 10. And that's where that little wacky sign comes from. And now, if you have an equation involving squares, like x squared is equal to 100, the answer to that is not going to be just 10, but plus and minus 10. You get two answers. And the reason you get two answers is minus 10 squared. That's minus 10 times minus 10. Well, when the signs are the same, the answer is positive. So minus 10 times minus 10 is 100. So minus 10 is another solution to this. On the other hand, if it's not a perfect square, for instance, x squared is equal to 7, well, x is still going to be the square root of 7, but we just put the little square root symbol above it and we just leave it alone. If we can't simplify it further. And then just a notational thing that a lot of people miss. The square root of 7 times the square root of 7. I find people find this difficult, but it's really right from the definition. This is the thing that when you multiply it by itself, you get 7. And that's why the square root of 7 is equal to 7. So another way to write this is typically these square roots and cube roots and everything else. You can use what's known as exponential notation, exponent notation. So the square root of 7 is the same as 7 to the 1/2. And so 7 to the 1/2 times 7 to the 1/2, well, the laws for exponents are when you have the same base, which is 7, and you multiplying them, you can add the powers. So you get 7 to 1/2 plus 1/2 is 1. And 7 to the first is just written as 7. It's just understood that the 1 is there. So those are all the preliminaries, and I don't think we took too much time there. And by the way, if you like these videos and you think you want to see more of them, please subscribe to the channel and like the video, because this is a new channel and we're buried deep beneath all the other similar channels. So no matter how good these videos might be, it's just hard. People never get to see them because they're like 100 deep below all the other channels. So if you like it, if you subscribe to it, that'll help. The YouTube algorithm will move it up further. So now, at long last, we're ready to solve this problem. So how are we going to, so let the two numbers be, we have to label them. So usually the first thing that you do with these kinds of problems is you draw a picture if you can. But if there isn't a picture you can draw, then what you do is you say, come up with some quantities, some symbols to represent the unknowns that are in the problem. And then you look for an equation or more that you can solve. So that's what you typically do. So what I'm going to do is I'm going to look at it this way. So we know that they have to add to 10. And we know that the answer isn't 5 and 5. So we know, what do we know? One of the numbers is bigger than 5. So I'm just going to write that as 5 plus x, where x is a positive number. Then what should the other number be? Well, if we're going to add it, if they're going to add to 10, this has to be 5 minus x, because that's the only way they're going to add to 10. And in fact, you can check that. 5 plus x plus 5 minus x, is that equal to 10? And I'll leave that for you as a check. It's just some simple algebra. You can check that it's going to work. So what we want is we want 5 plus x. When we multiply them together, we want to get 10. Now this is where we use some of the algebra we went over beforehand, because this is the product of two binomials. So we're going to use FOIL. We're going to FOIL that thing, and we're not going to be tentative about it. We're going to be very direct about it. So the first is 5 times 5, which is 25. The outside is 5 times minus x. A positive times a negative, the answer is a negative. Inside is 5 times x. And the last is x times x, but it's a negative x squared. X times x is x squared, and when the signs are different, the answer is negative. And we just copy over the 10. 5x minus 5x, well, 5 xylophones minus 5 xylophones gives us 0 xylophones. So we have no xylophones there, and all we have here is 25 minus x squared is equal to 10. I can rearrange this. If I add x squared to both sides and subtract 10 from both sides, what I'll get is, I will get, let me first add, so let me add x squared to both sides. So I'll get 25 x squared plus a negative x squared, that goes away. And on the right, I get 10 plus x squared. Now I want to get the x squared by itself, so I'll subtract 10 from both sides. And when I do that, I'm going to end up with, so if you would imagine I have a minus 10 there and a minus 10 there, I'm going to end up with 15 is equal to x squared. Well, here's where we use that property that we had gone over. X squared is equal to 15. That means what? X is equal to plus or minus the square root of 15. So we solved this for x, and we said that these were the numbers, right? So what's the answer going to be? Well, we need only plug in the square root of 15. Well, all you have to do is plug in the square root of 15 for one of them, and you're going to see that the other one is, so one of them, let's just pick this one. This will be 5 plus the square root of 15. It's clear that the other one has to be 5 minus the square root of 15. So those are my numbers. And they add to 5. And now if you want to check to see if they multiply to 5, let me just do one more. I'll just make one more slide here. Okay, so 5 plus the square root of 15. Let's check both. So if we take 5 plus the square root of 15 and we add 5 minus the square root of 15, does that add to 10? Yeah, it does, because these two cancel out. So that checks out. If we multiply them, do they multiply? Do we get 10? Well, let's see. This is going to be 25. We're going to use FOIL again. The first, 5 times 5. The outside is 5 times negative the square root of 15. The inside is 5 times the square root of 15. And the last is the square root of 15 times the square root of 15. But if you will recall from our previous discussion, that has to be 15. So it's minus 15. Well, 5 of these minus 5 of those are like terms because the square root of 15 and the square root of 15 are exactly the same. We're left with 25 minus 15. And what's 25 minus 15 is 10. So that checks out as well. So, thanks for watching. Like I said, any feedback you can provide is helpful. You can leave comments, and if you want to see something similar, let me know. And, don't be tentative about it. We have to be definite. All right. Thanks a lot, and I'll see you next time, probably tentatively.